In this video, we're going to solve the 2005 AP Calculus AB FRQ question Form A, question number 5. So it says a car is traveling on a straight road for between 0 and 24 seconds. The car's velocity v of t in meters per second is modeled by the piecewise linear function defined by the graph above. Find the integral from 0 to 24 v of t dt. Using the correct units, explain the meaning of 0 to 24 v of t dt. Okay, so for part A, we're finding the area from 0 to 24 v of t dt, which is going to make a little triangle right here. Sorry, I can't do it straight. Another triangle here. So we need to find this area and this area, and then also the rectangle in between. So now we're going to do 1/2 4 times 20 plus, what's 4 to 16, what's that, 12 times 20 plus another triangle, which is 1/2 16 to 24 is 8 times 20. So now we're going to get 2 times 20 is 40 plus 240. 4 times 20 is 80. So we're going to get 360, I believe. Now we have to explain what the meaning of this is. So since it says over here seconds and it says meters per second. Now when we answer this, we could say the car traveled, or the car travels 360 meters in 24 seconds. Okay, part B. It says for each of v prime of 4 and v prime of 20, find the value or explain why it does not exist. Well, v prime of 4 is not going to exist. D and E. Now let's go over why. If you try to find this, you're basically trying to find the slope of v of 4. And you can see clear as night and day, there's a corner there. So if you try to find the slope here, let's say you did v of 4 minus v of 0 over 4 minus 0. That is not going to equal v of 16 minus v of 4 over 16 minus 4. So v of 4 is 20, right? So 20 minus v of 0, 0 over 4 does not equal 20 minus 20 over 12. So you get 5 does not equal 0. That's why that one does not exist. So now, it says find v prime of 16, right? V prime of 20, I'm sorry, 20. Well, that one's going to exist because it's right in the middle of this. So v prime of 20 is going to equal v of 24 minus v of 16 over 24 minus 16, which is going to equal v of 24 is 0 minus v of 16 is 20 over 8, which is negative 28, which reduces to negative, divided by 4, negative 5/2 meters per second squared, right? Because that's the units. The first one was meters per second, so this one has to be meters per second squared. Okay. Okay, so now the next part says, let A of t be the car's acceleration in time t in meters per second for 0 to 24, write a piecewise function. Okay, so that's pretty easy. Part C is going to be a of t is going to equal 5 from 0 to 4. We found that part right there. And now the next slope was 0, right? From, what was it, 4 to 16? T less than 16. And then the last part was negative 5 halves. From 16 to 24. The only thing is, a of t does not exist at t equals 4 or t equals 16 because it's forming that little corner for the derivative. It's not differentiable. There. Okay, part D. Find the average rate of change of v over the interval from 8t to 20. Does NVT guarantee A of c for a value of 8 to 20 such that v prime of c is equal to the average rate of change? Why or why not? Okay, so for part D, I'm going to switch colors. And I'll do a blue. So part D, I'm going to fit it right here. Okay, part D. So now what we have to do over here is find the average. So v of 20 minus v of 8 over 20 minus 8. So v of 20 is, what's v of 20? 10? Does that look like it's 10? Kind of hard to read it. Let me look at it. Yeah, it looks like it's about 10. So 10 minus v of 8 is 20. Yep. Over 12. So now we're going to get negative 10 over 12, which equals negative 5 over 6 meters per second squared. And now MVT does not apply. MVT does not apply because of the corner at 16. Because, let me erase some of this so I could fit this. Okay. Okay, so back to this because of v of 16 is not differentiable. So MVT has to be continuous and differentiable everywhere in order for it to apply. I hope this video helps.